Hello, Mr. Suhu. We're talking about Unit 10 video. But first, let's just talk about that fight last night. I didn't like it at all. Even though I won $20 because I bet my friend Khalil $20 that Mayweather is going to win. And I'm glad that he won. But I still think the fight was horrible. Let's take a look at all the saltiness of people there was that night. Now, wasn't that something? They were so salty. My friend George, the boy you saw, he lost like $10. And Rowesha, she was just a hot mess. Okay, so let's start with our first thing. Our first thing is fundamentals accounting principles. So first, by the way, I create these problems by myself. We're talking about license plates. So in California, California license plate has 7 spots. 26 letters, 10 numbers, 1 picture, and 1 space. How many license plates of 7 characters can you create? Well, first, since there's 7 license plates, or 7 spots, there's 38. For each spot, you can create 38 total. Because for the license plate, or for the letters, it's 26, and then 10 numbers, 1 space, and 1 picture equals out to 38. And since there's 7 spots, you'll do 38 times itself 7 times. So after you get done with the math, it will be 114,415,582,592 different license plates you can create in California. Okay. So now our second thing is permutations and combinations. Well, let's talk about the difference between permutation and combinations. Permutations is when order matters, and combinations when order doesn't matter. So here's our problem. 4 reindeers, Lucky, Ruby, Rudolph, and Comet are used to fly a ski. You only have 3 slots. They fly in a single way, in a single line. How many ways can you arrange them? Okay, so first, since there's only 3, because order does matter, multiply. So in the first row, you can have a total of 4, because there's 4 reindeers. In the second one, you can only have a total of 3, because you can't repeat them. And then in your third row, you can have 2. So once you multiply everything out, you can see that you have a total of 24 reindeers. 24 different ways that you can arrange the reindeers inside if you only have 4 reindeers in 3 slots. Okay, so now we're talking about combinations, which is actually completely different from permutations. Well, the main difference is for combinations, order does not matter. So, here's our problem. You are packing for a vacation. You have 7 shirts, only 5 can fit. By the way, all these problems I'm doing, I am creating on my own. So, you have 7 shirts, and only 5 can fit. So, here you'll start off your equation. 7 with a probability, or not probability, I'm sorry, with a combination that only 5 can fit. So, you write it as 7 factorial over parentheses 7 minus 5 times 5 factorial. Now the factorial just basically means instead of writing 7 times 6 times 5 times 4 times 3 times 2 times 1, you just put that factorial and that would basically stand for it. So now you just want to write it out. So 7 minus 5 is 2. That's factorial. 5 factorial. So here, now we have 5 factorial of our factorials. So these will actually cancel out your 5, 4, 3, 2, 1. And then you're left with 7 times 6 factorial over 2 times 1. And that will equal to 7 times 6 divided by 2. And there goes your answer, 21. So there's 21 different ways that he can fit his 5 shirts inside his suitcase. Now, for combinations, it wouldn't matter which 5 shirts as long as because it all equals out to one group of 5 shirts. Okay, so when actually solving, oh my bad. Okay, so in actually solving which way is different, or which way for combinations and permutations, which one has more of an outcome, I have to rewrite it. So here's our problem for permutations now. You have 7 shirts, only 5 can fit in the bags. How many different ways is it possible to pick 5 shirts in the bag? Now notice we said pick. So now in this case order does matter. So now you just rewrite the problem. I did it this way this time. And once you simplify the 7 factorial over 5 minus 7 minus 5 factorial, you would get 2,520. So that knowing this will state that permutation has a greater outcome than combinations. Okay, so now we're going to be talking about two-way frequency tables. Oh, I'm sorry. Two-way frequency tables that I didn't create this problem because it was hard. So here's our data. 62 students participate in wearing yellow or non-yellow. Total of 12 green eyes students played. 20 people had non-green eyes and was wearing yellow. Okay, so now let's fill out this table. So, a total of 62 students participated, and a total of 12 people had green eyes, and a total of non-yellow and non-green people was 20. I'm pretty sure you can figure this out. So 12 and 60, 62. That would make 50 people. And now a total, and this will make 30 people, because 30 plus 20 equals 50. So now we have, okay, so I'm sorry, but I had to add something, I didn't see it. It said yellow was 40. So total of yellow people who had yellow was 40. Okay, so now we can go on and finish the rest. So 62 minus 40, basic math, which is 22. And non-yellow, so 22 minus 20 is 2. And then yellow, 10. 10 plus 30 equals 40. Okay. So now let's talk about how the probability can get added to it. So here's our question. Probability of someone wearing yellow. So now, back to our data table, we have a total of 62 people wearing yellow. So your 62 is your denominator and 40 is your numerator, because there is a total of yellow people wearing yellow as opposed to a total of 22 people wearing yellow. So your final answer would be 40 over 62, which can get simplified, if you keep simplifying, divide by 2, 20 over 32, or 31. And that would be your final answer. Alright, so now, let's talk about my favorite thing, which was Vegas. So now we're going to talk about the probabilities of winning, and how it can tell you your wins and your losses and the bets of a fair payout. So, now we have the roulette table. So for the roulette table and this is the actual table in Vegas with the double zeros, your type of bets, you have red or black, even or odds, 1 dozen, line 6, street, or straight up. So for example, let's say if you're trying to bet red, your probabilities of red is 18 out of 36, which equals to 9 out of 19 once you simplify. And because of this, you have your odds are for every 10 wins, no, for every 10 losses, you'll win 9 times, because for the 9 add 19. So this means that you will have a $10 payout, which actually you're supposed to be having greater money, because in Vegas they count as the zero and the double zero as if they don't exist, which means you get less money. So now let's move on to even and odds. Let's say you want to bet on even. Your probability is 18 out of 36, which equals to 9 out of 19. So same thing, $10 payout. 1 dozen, 6 out of 19. 13 out of 36, you get $13. Line 6, 3 out of 19, 16 to 3. So you get a $16 payout. And then your street, you get a 3 out of 38, which is a 35 out of 3 payout, which is $35. And finally, it's just a straight up, it's a 1 out of 38 probability and a 37 to 1 odds. So your payout would be 37. Now, how can this help you determine your bets of a better odds? So, well, in Vegas, it will be, you'll have less odds of winning now because of the double zero standards, which Vegas does not count. So, in reality, you're supposed to be getting, let's say in reality you're supposed to be getting $40. Your Vegas is only going to pay you 37 due to the double standards of the zero and double zero. Okay. So now let's start talking about craps. Probably the only game in Vegas where at the beginning you do have a greater chance of winning. So in craps you have your dice, and here are all the combination of dice that you can have. It's just all the random combinations. So the rules. In the game of craps, a player places a bet and rolls 2 dice. If the sum is 7 or 11, the player wins even money, the same amount as the bet. If the sum is 2, 3, or 12, the player loses. Otherwise, no money changes hands. So, in this table, it will show you that there is 6 sevens and 2 11s, which is your automatic wins. So for probability, you will have to do 6 over 36, because there are 36 chances, or there's 36 ways you can roll, plus 2. Plus 2 at 36, because there's 2 11s, and 6 at 36, there is 6 sevens. So once you add those together, you'll get there's an 8 out of 36 chances of you winning, which equals to 22.11% chances of winning. Now, your chances of losing, there's only 1 2, 2 3s, and 1 12 out of 36. So you just add those up, and once you get that, you will get there's 11 out of 1% of you chance losing. So your chance of winning is actually greater, but that's at the beginning. So let's say, imagine you start the game by rolling a 6. In case you have a 5 to 11 chance of winning the game and a 6 to 11 chance of losing. Explain why this is true. Then what would your chances be if you started with a 4? Okay, so your chances of winning is greater because the numbers does not matter as long as you get to a 6. Now say if you roll a 4. Now if you roll a 4, the chances of you winning are 3 out of 9. And the chance of you losing is 6 out of 9 due to when you roll a 4, you can only roll a 4 again to win the game, which is a 3 out of 36, which simplifies. And the chance of you losing is 6 out of 36, which is 6 out of 9 once you simplify. So in Vegas, actually, no matter what, at the end, you would not have a better chance of winning than the house. And that is why gambling is not always accurate and you would never get the exact same money. Otherwise, but Vegas is still very fun to play, and Vegas will always have the advantage no matter what. Okay, so let's talk about our life lesson. Which our life lesson was fight the laziness or love the grind. Now, I'm not always as successful as fighting the laziness because I'm lazy. It's very hard for me to do stuff, like even until now. I'm not gonna lie, I still wait till last minute to do these videos. Sunday night, which is now, which I said I did good time because it's only 8:27. 8:25 right now. Usually I wait to the very last minute. Now, fighting laziness has always been hard because at first I wasn't. We used to do sports all the time. And I guess once we sort of got older, I got tired of them. So now I don't do as many. So now I was very lazy. But in order for me to love the grind, for school, I look for that A. Now I want to do all my work so I can get that one A in that class. So I can get a better GPA and be more successful in life. So that's all I love that's how I love the grind. So I can look for a better future and better grades. But I'm still working on fighting laziness. And that is my Unit 10 video, and thank you for watching.